13 part 2. We just solved part 1, and let's see what changed in the requirement. Okay, in part 1, if you haven't seen it, we were folding one paper. We have some coordinates of dots, folding on X and Y, and we were folding our paper and counting at the end how many fillet points would be left. And the only difference with part 2 is simply to continue to fold the transparent paper up to the end. And what's the number of MNs left? Let's go to part 1. We solved that with the following program, and at the moment the only thing that we need to do is to see where we're stopping. Here we're having folding coordinates and we're passing only once, but in reality folding instructions, the only real difference that we need to do is, instead of breaking here when we see this instruction, is to have that like array and to append to it, and after that here to loop through and to read it. And for that reason I will do that simply programmatically. If you're really interested of how we get to that with ChatGPT to part 1, which actually was complicated, check probably my other video, or for you, before me actually trying that programmatically, let's try that with ChatGPT, because you've clicked on my video. Let's and we still have the prompt that we've been doing. That's the initial prompt, and we have the solution there, and now we can ask something else. And let's ask this part 2 prompt. We have prompt 1 for the part 2, and in our case GPT-4 continues from thank you the expected. However, there are new instructions. Could you modify the program to follow them? Task that build thank you, the program worked. The program works as expected. However, there is a new task what is the new task, part 2. We want simply to fold it to the end. As I mentioned in my previous videos and of my videos, what we do is we have test input, we have main input, we have our main Go program, and we're prompting ChatGPT with very with different inputs, because here we already have a program that is more or less working and we know even how to fix it. Let's do only one input to see if we would be able to get our program modified. If not, we'll simply get it ourselves. Okay, in our case we actually know kind of how to solve that. We simply need to get all of the folding instructions in array, exactly. After we have the dots, we have the folding, as the folding part and so on. Let's see if we'll do it. Already we can see that actually the temperature of the model and how much variation has, it's widely reduced, and it's iterating on the given program. However, the initial program actually was wrong, and we needed to add this line in which we were skipping actually empty lines, because if you look at the test input and so on, there was an empty line at the middle of the file, or empty line that was actually separating the coordinates for the fault instructions, and without that was simply going out of index and was trying to parse here the empty line to parse here it was getting empty array and was trying to parse the first and the second character of the string, which wasn't actually working whatsoever, the first run. But let's see how it does now. Okay, here we're doing that with A and X. I think it's instead of dot and the number symbol. It might be absolutely fine to do it like that. It might be wrong. Let's take a look and yeah, don't call it ourselves. I'm a bit disappointed. I wanted to solve it myself. It might turn out that I need to do that. Anyway, not sure that this A B thing would be actually working, but let's give a try. We had that. Which part we're missing actually? We're missing this that's clearing us why we use this Go program. Perform all the fault instructions, sort the dots by their y and x values, and construct the code by mapping x position of the top 8 dots to capital letters A to H and giving us the code. Like, what is... that's deconstructing the picture code. Oh, I missed this part. I was thinking that we'll continue counting the letters, but actually it's more complicated. I'm glad that I didn't try myself, because here we were getting this 0 number when we folded once, but actually here after the folding we would get letters, and we need to provide the letters as input. I missed that part. I was thinking that we should simply fold it and give the number of how many are visible, but not. Actually, we needed to deconstruct the letters. Actually, much better that I attempt that with GPT-4 for you, and that helps me. What I mean, my solution will not be so easy, because the deconstructing of this stuff wouldn't probably work as expected. Here we're crashing and going out of range. Why is that? As I said here, we simply need this check and having this continue. Was the same problem that we have previously with the input. Now we are having A, B, C, D, E, and let's see. I mean, that's okay. That's wrong. But why it's wrong? Because we're using the test input. 1 second, I get super excited and was using the completely wrong program. I mean, that book 2. Oh, I don't have. I need to wait. Let me, meanwhile, when I'm waiting for all this time to pass, check what we do. We go through the folding instructions. We are folding correctly. Once we have folded everything, presumably correctly, we sort the slices. We sort the dots using this function when they have the same y coordinates. You sort by x coordinate, and we're trying to have A to H code. But 1 second, what's our expected code here? The manual says the code is always 8 capital letter. But wait a minute. How we know that this 8 capital letter, this assumption to sort them by coordinates. This assumption here to me looks very strange, and it doesn't work, which is fine. I think let's, before get to this one, see how many. Let's go back to the test and test how the dots look without with simply ignoring this part here, because in our original program we were counting the dots, and we were doing that with this code. If I go back and I have the test input here, after the first fold we were getting 17. After the second fold here we're getting 16, but I actually okay, 16. Okay, it's only one overlapping. It seems correct. Okay, to that point we are up to here. When we need to visualize the thing, we're, so to say, falling apart. And I would say, I will ask simply to get a function that actually can visualize the points before to get to this wrong parsing. And let's try that, because here it's obviously we continue with our prompt 2. Could you write me a function which visualize the paper after the following instruction? Could you write me a golang function I want the function to a list of dots because here I want to have list of dots and to using fmt print and put here. Very important part is and for missing put a dot and okay, I think that's more what we would want to see, because in this way we'll be able to okay, it's already doing it correctly. It's finding the max of x and y, and it's going in them and it's checking. Okay, is here a coordinate? If not dot, it's printing a new line. Absolutely magical. It's exactly what I was thinking to do, but so to say, done better than what I would do. It's really I start seeing, especially for these coding challenges, when I compare with when I was solving this stuff myself. And yeah, I know that is definitely beneficial to solve it yourself, and to struggle to some of these problems, especially because they're the same thing repeating. Still, here I can see a lot of value, especially in this visualize part. Let's grab that one. Let's see how it's visualizing for us. We'll put it here at the bottom. In here, instead of doing this counting that we're kind of confident that's the case, we want to have the dots here and see in our small case we're getting okay this letter. However, in the let's see what we get in the correct input. Okay, we're getting A okay. I think in this case simply this sorting kind of logic didn't really work, because when you visualize it here, and the code that we're getting here, would it be A H, let me make it bigger for you to be able to see it, is H A P R P A U Z. It's what looks to me. All of this slicing and ordering the coordinates and so on it doesn't seems to be working, at least PRPA. Yeah. Of course there is some mapping that we can do, but because we have these eyes, yeah, it will be magical if we can revisit this task and see if the new GPT-4 that can accept images can do that. Because here it's one shortcoming to translate this mapping to this string that's not trivial whatsoever. However, because how we process data and so on, and we know how wide uh, a letter is and so on, we can do that very easily. But for a program, yeah, that's not as easy. But no matter that, yeah, I think the solution and the result, and especially this help from here, it's absolutely fantastic. uh, Hope you enjoyed that, and see you next day. Bye.